Okay, good evening to everyone. My name is Gopal Krishnan. I'm one of the resource person. I work as a PGT in PS Senior Secondary School, and there is one more resource person who is my principal. Ma'am, would you like to introduce yourself? Ma'am is there? Okay, the other resource person is Dr. Revati Parameshwaran. She is the principal of my school. Am I audible to everyone?
Yes,
Is
sir.
it clear?
Yes, sir.
Okay. So in the GeoGebra workshop, basically, we are going to talk about very elementary things. Right from the scratch, what exactly you should know about GeoGebra. Okay, right from the beginning, we are going to do. And நான் செய்யும்போது கூட நீங்களும் வந்து ட்ரை பண்ணணும். So if I go fast, please put your comment in chat box so that the people will share it with me, or you can just unmute yourself and tell me if it is fast, if you're not able to follow or if you're having some difficulty. Okay, the first thing, as usual, we'll just go to the basics. Like you see, this is file. You can create a new window. I think you should be knowing all these things, just like the way you do in Word. Okay, new, open. If you already have an existing GeoGebra file, you can always open this. And of course, we'll come to these things little later. Right now, it's not required. And you know the save button and save as. Okay, just I would like you to just click on the file and just see and browse it and see. It has new, open recent files. In case I have opened some recent files, so it's there. You can save the file. You can save it as a PNG format. You can if you want to save it as a picture format, you can save it as a picture format. If you want to save it as a PDF, you can save it as PDF. It's up to you. That's first thing. Now edit, as usual, you have copy, paste, those things. It's very simple. There's nothing much in this. Now the view tool is very important. Let me go through one by one. First one is, you see this panel here. This is called the algebra window. So if I click that algebra window here, it will go away because I have selected it. So if I want to see the algebra window, I have to click on the algebra window. You see, this is an algebra window where whatever I am typing here, whatever we do, the functions, the value, everything will be seen there. This is the algebra window. This is the spreadsheet, just like you do Excel spreadsheet, you can see. This is the Excel spreadsheet. If you don't want that Excel spreadsheet, click on that, it will go. We'll see later. This is the graphics window. See, the one which you're seeing here is called the graphics window. This is where all your graph is going to be seen. This is the graphics window. If I click on that, the graphics window will go. If I want the graphics window, I have to click. I get the graphics window. In the toolbar, input. This is called input bar. If I click, the input bar will go. If I want, I have to click on that again. This is an input bar. You have a keyboard also. If you want a keyboard, you can type a keyboard. If you don't want, you can get rid of it. So once again, what is required only we'll do right now. You need an algebra window. You need a graphics window. And you need an input window. You need algebra. You need graphics. You need input. Okay. You can do, there are so many, even there's a 3D window. So if I click on 3D window, you'll see a 3D window here. If I don't want, I can just exit. You get, this is a 2D graphics window. That was a 3D graphics window. Okay. Just to take few minutes to explore that. Look at the view. You also try it and see. Click on algebra, click on CAS, see what gets open and how to close it also. Just I'll give you 2 minutes time, you just go through that. On the viewer, click on it, you try all these things. probability window. You can even calculate all types of distributions, Poisson, normal, binomial. You can think of anything you can do. Okay. Can I go to the next one? So I think you should have understood by now. This is an algebra window once again. Algebra window. This is a graphics window, and this is an input window. In the graphics, you can see grid. If you don't want the grid, you see there's a graphics here. Can you see there's a graphics here? Okay. If you click on that and click this, the x-axis and y-axis will go. If you don't want the grid, click on that. Click on this grid. The grid will go. If you want the grid, click back again. If you don't want the axis, click that. Axis will go. If you want the axis, do it. Just try that and see. Whether first you try to remove the axis and bring back the axis. Adukapurama remove the grid and bring back the grid. Just take a few minutes to explore this. Okay. Now these are all called toolbars. There are plenty of toolbars here. I'm going to go to one by one. What is required, we'll do. What is not required, we'll leave it. Now first, I'll go to this point toolbar. Look at this point toolbar. You see there's a small projection here. If you click on that, you'll get the first a point into the select point. Suppose I want to plot 1, 2. Inga 1, inga 2. Just go and say 1, 2. This is the algebra window. You can see the point. A is 1, 2. Can you try plotting 2, 3? Just plot 2, 3. Click on the point. Click on the point. And click at 2, 3. You get the point. A, B, and if you get a point at go to that point, right click on it. Go to object properties. You can make a note also of these things. Object property. A window will come. If you see show label, there's a name. There's a pull down menu. Click on that. If you say value, it will give you the value. But if you say name and value, it will give you name and value. So point A, 1, 2. So can you please try it for B? Try to get the value of B. Go to point B, right click on it, go to the object window. This window will come, and if you select value, the value will come. The value will be seen. If you want to see name as well as value, that also can be seen. Now, suppose you want to move this point around, very much possible. See this, look at this one. This is called the move tool. Click on that move tool, and you can drag this point wherever you want. You can take it wherever. Suppose you want to keep it at 10, 0. Keep it. Correspondingly, the algebra window also will change. This is 10, 0. Let me take this B to origin. 0, 0. So you have learned now two tools. One is the move tool. The other one is the point tool. This is the point tool. And there's one more tool called point on object. So you need an object. So now I'm going to take you to the input bar. Look at the input bar. And I'm going to draw the graph of y equal to x squared. One more thing I want to tell you. Suppose I don't want to see this point A. All that you need to do is go here, click on the dark thing. If the darkness goes, the point will disappear. If you want to bring it back, click on that. The point will come back. If you don't want B, remove that B. It is not deleted. You are hiding it. You are not deleting, you are hiding it. If you click it back, the point will come back. Is it clear? If anyone feels it's faster, please let me know. So I'm deleting the point. You can right click on it and delete. Now I'm going to go to the input bar and type. See what I'm typing. Y equal to x square. X on the keyboard மேல இருக்கு பாருங்க. It's on top of 6, number 6 மேல இருக்கு. So y equal to x square. Immediately you get a graph. Y equal to x square. So the input window is used for plotting graphs. Y equal to x square. Now what I do, I choose a point. I choose the point tool and click here. Wherever you want. I click on this. I choose point on the object and click on this. Somewhere else. I choose it B. Now I take the move tool and drag point A. See what will happen. It moves around. You see, it will move around that object. It moves on. If you choose the point on the object, it will move on that object. Whereas if I choose a point here, not on the object, this point can be dragged wherever you want. Whereas this point cannot be dragged anywhere. It can be dragged only along the curve. It will be dragged only along the curve. So that is the difference between the point tool and point on object. Okay. Now I'll draw one more curve, say 2y plus 3x equal to 4. I got a straight line. I want to find the point of intersection of this graph and this line. So what do you do? There is a intersect. You see there's an intersect on point. You drag down the fourth one. It is called intersect. You select that, click on both the graphs. See, I first click on this graph, y equal to x square. Then I click on the line, I get the point of intersection. I get the point of intersection. So, just to give you a recap, I have explained to you what a point tool is, point on the object, and how to find point of intersection of two curves. Point of intersection of two curves. Okay, and I also told you how to draw this graph in the input box. Okay, now you can try two functions that you know. You can try y equal to 4x square. Y equal to 4x square or 4x cube, whatever you like. Y equal to 4x square, and then you draw one line and find point of intersection. Take some time and explore that. Explore these three tools: point on the object, intersection of two curves, and the move tool. Just explore that. Any doubt? Any questions? Can anyone give comment on the chat box? Let me know in case they feel it's fast, if they are not able to follow anything. Is it clear to everyone? Can I go to the, would you like to try these things once again? Point on the object, intersection of two curves, and move tool. Okay, now let's come to this point. This is called the line tool. This is a line tool. Okay, I'm going to talk about the line tool. So for that, if you want to draw a straight line, you need 2 points. So I click 2 points. Wherever you want, you choose 2 points. Select this line tool. So if you go on that only, it will tell you. So can you see, select 2 points. So it will give you guidance also. So click on point A and click on point B, you get the line. And you can see in the algebra window, its equations also given. So you also try it. You also take 2 points wherever you want, select the line tool and try it. Take any 2 points. First you select 2 points from the point tool. From here you select 2 points. Select the line tool. Click on the 2 points, you get the line. This is a straight line extending to minus infinity to plus infinity. It's a continuous, like no end. It's a straight line. It's an array. Now, I don't want to see this straight line. I don't want to see. So what you will do? Go to the line. See, this is the equation of the line. Click on that. That line will go. Now I want to draw a line segment. See, that was a line. I want to draw a line segment that is from A to B. To select 2 points. Here also it gives you guidance what you should do. So select A and B. Finished. This is a line segment. The equation of the line segment is given, and this is also gives you the length of the line segment. This also gives you the length of the line segment. So you have learned the line tool, you have learned line segment. Now, how to draw a line of given length? Okay, we'll see that. Click that line of given length. Choose anywhere, wherever you want. Click. It will ask you what length you want to draw. I want to draw 4 units. I get a straight line. It will draw only horizontal line. And it is impossible for you to move also. Beyond that, see, you cannot extend that line. Whereas this line you can extend wherever you want. This line can be rotated, but it cannot be extended. You cannot increase the length because it is a line of a given length. So that is the difference between the line segment and segment of a given line. See the difference. This you can change the length wherever you want. You can move around. Whereas this can only go around. The length cannot increase. You can also explain to your students about the locus of a circle, how a circle is generated. Just to explore that. So once again, we have talked about point. We talked about point on the object and intersection of two curves. And then I told you about the move tool, and you tried a few things with your input bar. Input bar where you can write the function, the graph will be drawn. Then we did the line tool, line. Then the line segment. Then segment of a line of given length. And you know the difference between a line segment and segment of line of given length. This you can increase and decrease the length and change positions. This you can only go around. The length cannot change. So you take few minutes to explore that. Then we'll go to the next step. Okay. And these are all the tools which we will be using it. Okay. How to draw perpendicular lines, parallel lines. See, perpendicular line, very simple. Click on that. Suppose you want to draw a perpendicular line, perpendicular to x-axis. Click on x-axis. Wherever you want, you can draw. If you want to draw the perpendicular at 3, 0, yes, you can draw it. You want to draw a perpendicular line to y-axis, click on y-axis, Wherever, if you want to draw it at 4, 0, draw it. Suppose you want to change the color of this line, right click on that, object property, right click on the line, object property, there's a color here, select the color you want. Try to change this color. Right click. Here I will do it differently. Go to the black, you see, look at the graphics window, algebra window. Right click on that, change it to blue color. You see? You can either click on the line or on the object, or you can click on the equation. Both will give you the same impact. Now, what is parallel lines? See, look at parallel lines. I want to draw a line parallel to this line. So, select the parallel line, click on this line. See, you can draw it wherever you want. Suppose I want to draw it at 7, 0. Okay, 7, 0. I want to draw a line parallel to this. Click on that line. Wherever you want, you can draw it. Finished. So, this is the use of perpendicular and parallel lines. Perpendicular and parallel lines. Just try, just explore it and see. Try to change the color. Right? And you can also see the equation of the line. That is very important. Also look at the equation of the line. Select the line. Select this tool, perpendicular, parallel. You have done these two. Perpendicular and parallel. Now I'm going to go to the third tool, which is the perpendicular bisector, which is a perpendicular bisector. So for that, I'll choose 2 points, connect them by a line segment. You cannot choose line because it's an infinite length, so you cannot bisect it. So line segment, 1 second, something's wrong. Okay, choose 2 points wherever you want. Choose the line segment, click on this point, click on this, you get the line segment. Now go to this perpendicular bisector, click on the perpendicular bisector. If you go on top of that, it will tell you what to do. Select 2 points. So I'm going to select 2 points. I want to bisect these two. Click this, you get the perpendicular bisector. This will be the middle point. How do you find point of intersection? I want to find this point. How do you find it? Go to point, intersect, select the first line, select the second line. It will give you the point of intersection. You can see the coordinates. And explore and see. So just move this around. The perpendicular bisector property will never change. It will never change. It will never change. It will remain as it is. So once again, I'll just give a small recap. We have done point on the object, intersection. Then you have done with the move tool. Then line segment, and segment of given length. You have done parallel and perpendicular lines and perpendicular bisector. All this will come little later. It's very obvious, angle bisector. Suppose I want to bisect this angle. Very simple. Select angle bisector, click on this line, and click on this line. It will give you the angle bisector. It will bisect the acute as well as the obtuse angle. I'll change this color slightly. This red line, since here it is 90 degrees, you can't see the difference. Otherwise, okay, we'll just change it slightly. 1 second. Okay. This red line is the obtuse angle made. It's obtuse angle bisector. And this is the acute angle. So red line is one angle bisector. You know there are 2 angle bisectors. The black is one angle bisector. The red is the other angle bisector. So we have explored angle bisector also. So just try it and see. You just draw 2 lines. Just see this. How to draw? Just draw a line segment. Draw another line segment. Now I want to draw angle bisector. Click the 2 lines. You get the angle bisector. So like this, we explore. Only if you explore, if you are doing it for the first time, you have to explore. So we have done the point tool, point on the object, intersection, move tool, line segment of given length, perpendicular lines, parallel lines, perpendicular bisector, angle bisector. Okay, so we'll stop with this and we'll do some small little activity and try to use these tools first. First, let's use these tools. Here, if you notice, there is something called text tool. So I'm going to type what I'm going to do now. I am going to, so just again, I'll show you how to do it. Go to this place. You look at this last but one, second one, ABC. That's a text tool. Click on that. Click wherever you want. A window will come. Now I'm going to type. What I'm going to do, I'll tell you. Sum of angles in a triangle is 180 degrees. I'm going to verify this. If you right click, it will come there. Of course, you can increase the size, font, everything that you can do. I'm not interested in that. Right now, let us focus on this. Sum of angles in a triangle is 180. Please, I would like you to type that. Sum of angles in a triangle is 180. In your window, select the text and type it as sum of angles in a triangle is 180. If you have done that, you go to the object. You can change the color. You can increase the font size. You see, there's a text. I want a very large. You decide what you want. Large. The sum of angles in a triangle is 180. Some other color, whatever color you want, you decide. Now, how am I going to do this? If you want to draw a triangle, you need 3 non-collinear points. So, what tool will I use? I have to use the point tool. So, I select the point. I select 3 non-collinear points. 1, 2, somewhere here I'll choose 3. 3 non-collinear points. Now, how to draw the triangle? Here, I'm going to go to this tool. You see, look at this. The fourth one, after this perpendicular, parallel, and all, you see there's a polygon tool. There's a polygon. Don't go to regular polygon. Choose polygon tool. Polygon tool. All that you need to do is click on the vertex A and just move B. See, automatically to draw the triangle for you. So I have introduced you to one more tool that is called the polygon tool. I have introduced you to the polygon tool. What do you do? First, you use the point tool and select 3 points. Use the polygon tool and select 3 points. After selecting 3 points, use the polygon tool. And if you go there, it will give you the help. Select all vertex. Here it is a triangle, so I'm selecting 3 vertex, you get the polygon. Just try this. Choose 3 non-collinear points. Choose 3 non-collinear points. and then go to the Polygon tool and draw the polygon. Okay. Now I want to measure all the angles here. There are two ways to measure. One way is, you see here, look at this, look here. After polygon, you have circles, you have a conic section, then you have angles. You see the first one, angle. I select the angle. Okay. Since it is a polygon, I go inside the polygon and click. We get all the angles. I just go inside and click. Again, select the angle, go inside the polygon and click. You get all the angles. Actually, the numbers are not so clear. So use the move tool, go on that and just move. So you can see it clearly. Alpha, beta, gamma. You can see all the three angles. It's very clear. Accidentally, it has become 90 degrees. Okay. I'll change it. People should not think it should be 90 degrees. So I hope you understood how I did it. There's another way to measure the angles. I will give you the other way also. Select the angle tool. I want to measure each one individually. So do it in the anti-clockwise direction. Click on this line. You get the angle. Now I want to measure this angle. This line and this line. It will give you that angle. Then click this. Suppose I accidentally click the other way, clockwise. What will happen? You get the other angle, which I am not interested in. So I'll click it in the right direction. Just try it. It's the same thing. Either you can do the first method or the second method. First method or second method. Now I want to check whether the sum is 180 or not. See, I'm going to the input bar. Look at the input bar, what I'm typing. I just type sum of. Okay, sum of all the angles. Okay. So what is that? Sum of equal to, it should be in bracket, curved bracket. Alpha is very difficult for me to type. So click from here. Alpha plus beta plus gamma. Plus enter. You can see clearly the sum of angle is 180 degrees. So the theorem is simple, but you see what all tools you used. To make this activity, you use the point tool, you use the polygon tool, then you used angle between two lines or angle in a polygon, and finally in the input bar, you type the command. What is the command? Sum of all the angles. Sum equal to, this is a syntax. The sum of angles, you can call it any name you want. Sum of equal to alpha plus beta plus gamma. It has to be in curved bracket. If you don't put the bracket, it will give you syntax error. So sum of equal to, you can call it whatever name. I wrote it as sum of. You call it any name, but the command should be any name equal to bracket alpha plus beta plus gamma. If you have difficulty with typing alpha, beta, gamma, don't worry. You can right click on this and say rename. And you can rename it to A. I'm just telling you how you can do other way. Or you can call it E. Now that angle will become E. Okay. Now right click on this, rename, call it as say H. Now it will be hereafter called H. If it is very difficult for you to remember it as alpha, beta, gamma, you can do it like this. You try, you explore and see. All that I did is point tool selected 3 points. Polygon tool constructed the triangle. Angle between lines or angle between polygon, I found the angle. In the input bar, I checked whether alpha plus beta plus gamma is 180. Finished. Automatically it gives. And use the move tool and give it some stretching. You stretch wherever you want. You see, the sum of will not change. The angle will change, but some of the angles will remain 180. Instead of just dictating the theorem in the class, if you do it as an activity, if you show these activities, students will understand things better. Wherever you want, you just explore. This is how you explore and see. So you try it and see. Take 3 points, construct a polygon, measure the angles, and check whether the sum is 180 or not. And check whether the sum is 180 or not. Okay, now I'll move to the next one. I'll go to the next one. Now I'm going to tell you how to construct a right angle triangle. How to make a right angle triangle. So first of all, what I do, I choose 2 points. I'll take one as horizontal. I'm purposely not choosing it at origin. Okay, not choosing it at origin. I choose wherever I want. I choose it at A and I choose it at B. Now I want to join AB. So what tool I should use? So I assume that you're answering me. I'm going to use the line segment tool. Click that. So you get the line segment. Or otherwise, this is also not required. Select 2 points A and B. That's enough. A and B. Now what I'm going to do is draw a line perpendicular to AB. I want to draw a line perpendicular to AB at A. See? I click the x-axis and I do it. Once again, I think that will be a little confusing. So let me draw line AB. Then I'll draw a perpendicular to that. Otherwise, you may get confused. Perpendicular to AB at A. And now you know what I should do. So I have got AB. I need one more vertex. And obviously, I'm going to choose the vertex here. So click. Should I choose point or point on the object? So I assume that you have answered me that it is point on the object. So I choose it here. Wherever I want. Now I want to make the triangle. So what tool I should use? Polygon tool. Click on the 3 vertex. You get the right angle triangle. Let us once again find out what it is. First of all, I choose point AB. I choose point A and B. Just choose anywhere. You can choose it here also, no issues. Choose point AB. Now you connect them. Connect them by a straight line. Now I draw a perpendicular to this line at A. If you want, you can draw it at B also. These are the things that you have to explore. So I draw it at A. Now point on the object. Point on the object. Wherever I want, I choose a point. Now I got three vertices. Choose the Polygon tool and construct the triangle. Now I want to measure all the angles. I want to measure this angle. Especially I want to measure this angle. How do I measure? Select this angle tool, anti-clockwise direction. Don't forget that. Click on this leg. Click on this leg. You get 90 degrees. So we have constructed a right angle triangle. Now you can see, interestingly, if you move this, you get so many right angle triangles. So many right angle triangles. In one shot, you constructed infinite number of right angle triangles. I just zoom. I use the zoom tool. You see, this is a zoom tool, and I just want to zoom down, or I can zoom in if you want. You can zoom in, or you can zoom out. Or if I want to drag the entire window, you use this. Click on it like a hand holding the screen. Pull it down, you can see it. So I have constructed a right angle triangle. You also try it. Suppose I want to find the length of each one. Very simple. It's already given here. If I want to see it here, right click on it, right click on A, go to object property, name, value, or you can say name and value. So it will give you name as well as value. Go to the object property, click on name and value. It will give you name as well as value. Again, right click on this, object property, name and value. If I want to move this 90 degrees outside, what do you do? Move tool, click on that and just move it. If I want to move the vertex A, bring it down. All these are possible. Now I'm going to verify Pythagoras theorem. What does Pythagoras theorem states? So I'm going to use the text tool. What does the Pythagoras theorem say? Sum of the hypotenuse equal to sum of squares of the other two sides. I think is the text. And press OK. Sum of the hypotenuse is equal to sum of squares of
square of the
other two sides. So it has come here. And you know how to change the color, you know how to increase the size. I'm not going to go to that. Now I'm going to verify Pythagoras theorem. How? I'm going to go to this polygon tool. Now I'm going to introduce you to another tool called regular polygon. Click on the regular polygon. Click at vertex C and vertex B. It's a four-sided polygon, so you get a square. You see this poly 2 represent area of that square. Just have a look at it. It's the area of that square. Now I click at A and I click at this point. I should have taken the other way around, this way. You get a square. So you got the squares. Look at the values of poly 2, poly 3, and poly 4. You add poly 3 and poly 4, you will get poly 2. That is Pythagoras theorem. Sum of squares. What is C square means? C square is nothing but area of the largest square. A square plus B square, area of the other two small squares. So poly 2 plus poly 2 equal to the area of the largest square equal to sum of the areas of the other two squares on the other two sides of the right angle triangle. Just check this Pythagoras theorem. It's very simple. You can even right click on this polygon just to show some difference. You can change the color. You can change this color also. Just to show. Sometimes these colorful things makes the students gets interested. One second, something's wrong. Click on this polygon and change the color. Click on this polygon. What color you want, you can choose it. If you want to darken it, just pull this. It will darken. It all depends on what opacity you want. Just look at this. The red color area is equal to sum of the other two areas. So just verify it and see. Once again, you try. So let us see how we constructed the right angle triangle. First, I chose A, B. First, I chose A and B. First, we chose A and B. I drew a line segment AB. Then I drew a line perpendicular to AB at A. I chose a point C. With the three vertex ABC, I constructed a right angle triangle using the Polygon tool. Then I verified Pythagoras theorem. You can see verified Pythagoras theorem. How do I verify Pythagoras theorem? All that I need to do is construct the square. Automatically you'll get it. So I would like you to try that now. Just give it a try. See, here the most important thing is what are the tools that you're using. So first you use the point tool and selected A and B. Then you use the line segment tool and joined AB. Then you use the perpendicular tool and constructed the perpendicular to A. Then I used point on the object and chose the point C. Then I used the polygon tool and constructed the right angle triangle. Then I used the angle tool and measured the angle 90 degrees. So that is how my construction of right angle triangle is over. Now how do I verify Pythagoras theorem? I use the regular polygon tool, I clicked on these two vertices, I got the square. Similarly, you click on the other two vertices, you get the other two squares. And clearly you can see Pythagoras theorem is verified. If you want, you can change the positions and see. Change it and see. It will definitely satisfy. Now this is a beautiful isosceles right angle triangle. Isosceles right angle triangle. Where this is 19, other two angles are 45. If you want, you can verify it. Just click on this. Choose the angle tool, click inside the polygon. You get oh god, angle and where's the polygon? You get all the angles. Explore and see. You just see, just move around, just move around and see. you'll get it. So you take some time and just to try this. Then we'll go to the next one. You take few minutes and see whether. See, the important thing is not verifying Pythagoras theorem. Important thing is how am I using these tools. Only if you know the usage of these tools, once you understand how to use these tools, you can, with your maths background, you can always create all these things. So just understand the tools. To draw right angle triangle, first I need the base. To draw the base, I need 2 points. So I choose 2 points. Now the base is connected by the straight line. Then I need to construct a right angle. So I have to draw a line perpendicular to AB. So automatically I need the perpendicular tool. Now to draw the triangle, I need a vertex. Why should I choose? It should be on that perpendicular. Choose the point. Now that you have 3 vertices, easier triangle varailam. Use the polygon tool and draw the triangle. Now I have a doubt whether this is 90 or not. So I go to the angle tool and measure. And definitely it is 90. So you have constructed the right angle triangle. Once you have constructed the right angle triangle, now using Pythagoras, you want to verify Pythagoras theorem. How do I verify Pythagoras theorem? Then I have to understand what is C square. C square into the area of the square with side C. So if this side is A, area of the square will be A square. So A square equal to B square plus, I don't know what this alphabet is, C square. Simple. You take some time and do it. If you do, you'll understand. Okay. Okay, we'll come back to triangles once again, once we explore all this. So with these activities, I'm trying to explain to you the usage of these tools. So to some extent, you should have understood now how to use the move tool, point tool, point on the object, intersection, then of course the line segment, line, a line of given length, perpendicular line, parallel line, okay, and polygon tool, regular polygon and regular polygon, and then angle tool. Then you have done text tool, how to use the text, you have used it. How to zoom in and how to zoom out. See, you can zoom in as much you want. And you can always zoom out. And use this to move the graphics. Wherever you want, you can move it. So these are some of the tools that we require. Now I'll show you something else. I need the grid, so I take the grid. And I also told you how to remove the axis, how to insert the grid, how to remove the grid. Okay. Now, I'm going to go to this tool now. Look at this tool. There are some very interesting things here. Circle with center through point. Suppose if I click that, this is the center, and you click there and just move the mouse. Automatically the circle will go on. Wherever you want to stop, you stop. Suppose you want to stop here, you stop there. So this is the circle. This is circle with center through a point. Circle with center through a point. Try it and see. Circle with center through a point. Just click wherever you want, move the mouse and click another place, you'll get the circle. Suppose I want to draw the radius. Join this line segment. Line segment. So I'm able to draw the line segment. That's called the radius. Okay, what is the length of the radius? Obviously, from the algebra window, it's clear. But if you want it to be very clear, if you want to tell someone you want to measure, you see here distance. You see this is called distance or length. Distance or length. It is third in the angle thing. Select that. If you go on that only, it will tell you what to do. Select 2 points or line segment, whatever. So I select A, I select B, I get the radius. So it will give you the radius. Can you see it? It's the same thing. 2.16, 2.16. Increase. Use the move button, change it and see. The radius will change. So this is how you explore. So once again, I have introduced you to some tools. First tool is how to draw a circle with center through a point. Then from the center to the point, if you connect, it's called radius, obviously. And how do you do that? Using the line segment tool. Now I want to measure the length of the line segment. How do you do it? Go to this angle, third from the distance or length. Select that. Click these 2 points. It will give you the length. Just explore and see. See, to do the simple things, you need to use so many tools. Until unless you're familiar with these tools, you won't be able to. You may have ideas, but until unless you know these tools, you won't be able to execute it. So I hope you tried it. So I'll move to the next one. Now, the second one is circle with center and radius. So what is that? So I click here at origin. It will ask for radius. Suppose if I put radius is 5, it will give you a circle of radius 5. See the equation: x square plus y square equal to 25. It's the equation of a circle with center, origin, and radius 5. Now I'm not able to see it clearly, so I'm using this tool and I'm going to drag it. Now I'm able to see. The circle is too big for me to visualize, so I use zoom out. So it's okay. Now it's clear. Now I don't know where it is intersecting here. So what I do, you can click this tool. You see this move graphics. Go on the x-axis. You see that arrow mark comes. Just slightly change. It will change the axis. You can do a lot of things. Go on y-axis. You can change. See the scale changes. It is still a circle only, but the scale is changing. So this tool helps you to draw a circle with center and given radius. Circle with center and given radius. Okay, now I'm going to verify few results. What are the results I want to verify? So I want to tell you what results I'm going to verify. So I'll type here. Angle in a semicircle is 180 degrees. Now how do I verify angle in a semicircle is 180 degrees? So for that, first of all, I draw the diameter. Select here. You get the diameter. Okay. Now choose any point on the circle. Any point means Should I choose point or point on the object? I'll choose point on the object. Wherever you want, you plot it. Now use the polygon tool and draw the triangle. Now measure this angle. To measure the angle, what I do? I use the angle tool, anti-clockwise direction. You see the angle is 90. You can see clearly the angle is 90. If you can't see clearly, move it. Okay, it's not working. This is 90. Again, I'll repeat, I drew a circle and I drew the diameter. I chose a point on the circle and I just completed the polygon. And angle is 90. Now explore and see, just move it around. The angle never changes, it will be 90. So this tells you angle in a semicircle is 90 degrees. Here it is 270, it's an exterior angle. So the interior angle will be 90 degrees. You can just go around and see. Okay, if you're lazy to go around, there's another technique. Go to the point, right click, there's something called animation. Click on it, it will do by itself. This will help you to show that angle in a semicircle is 90 degrees. So I have introduced you now to a word called animation. If you want to stop it, you see there's a stop button here, just stop it. If you don't want animation, right click on it and click animation, it will go. Okay. So that finishes this part. Angle in a semicircle is 90 degrees. Okay. Now what is the next theorem I want to verify? Angle in the same segments are equal. Angle in the same segments are equal. I want to verify that. Oh God. Instead of OK, I said exit. Angle in segments are equal. Okay. Get angle in the same segments. This is the second result I want to verify. So first of all, I'll choose 2 points. I'll choose it here. Wherever you want. Wherever you want. Point on the object. I'll choose point on the object. Point on the object. Everything is point on the object. So point on the object. Now choose 2 other points. Wherever you want. Now connect them. You can use the regular polygon, that is better. You see this? Regular polygon. I mean the polygon. This is the polygon. Now I want to know these 2 angles. How do I do that? This is the polygon tool. Now how do I measure the angle? Use the angle tool. Anti-clockwise direction. Don't forget that. Look at the angle. It is 40.79. Measure this. We'll see. This is also 40.79. Now explore. Move it around and see. It will never change. Angle in the same segments are equal. Wherever you move. Wherever you come. Whatever is the point. Change this and see. Change this. Here also you can verify angle in a semicircle is 90. Sometimes because of the scale problem you may not get exactly, but doesn't matter. Angle in the same segments are equal. You can even bring it to this side. And you can verify angle in a cyclic quadrilateral is 180. You can add it and see. Angle in a cyclic quadrilateral is 180. This is You have to take the exterior angle. Okay, we'll do that separately. Otherwise, I have to subtract from 360 and add it to this. Or you subtract this angle from this. Automatically, you get 180. This you can verify. See, both the angles are same. Whether it is in the minor arc or in a major arc, angle in the same segments are equal. Instead of just telling them as a theorem, you can always show them like this. Then student will understand. So to do this, what all I did, I took a circle. I took 4 points on the circle, and I constructed. I fixed 2 points as one segment, and I constructed the other two angles, and I got angle in the same segments are equal. Now, one more result, if you want, you can verify. What is the result? Angle at the center is twice the angle any point on the remaining part of the circle. I'm also showing you how to do the text tool. So it's here. So for this, what I do, I use the Polygon tool and I connect the center with this. You see, I'll change this color because to show some difference. Let me take it blue color if you want, and increase opacity a bit. Now I want to measure this angle. So right click, angle, and just check the angle. This is the angle. You can see clearly this is double this. So you can move around and see. You change it to any position. Change it to any position. This is 41.57, that is 20.78. So angle at the center is always double the angle at any point on the remaining part of the circle. So in this diagram, you are able to show all the theorems. You are able to show angle in the same segments are equal. You can show angle at the center is twice the angle at any point in the remaining part of the circle. You can also show angle in the semicircle is 90 degrees. Everything is shown. So it's very interesting activity. So the activity, I'm sure you all know the theorem very well, but what I'm trying to say, to do this, see the tools that I'm using. I selected a circle, I selected 4 points, then I used the Polygon tool and constructed and took angles. That's all. Automatically you get these things. So take some time and just explore it. You just try it for yourself. Just take a few minutes and try. Okay. Now we'll go back to triangle. I will introduce you to slightly difficult one. All this while we have been doing very simple things. A slightly difficult. See whether you are able to get it. Now, what is this result? This you need to write in case you want, so that you can try it later. Because this is little complicated. Because we have been doing all simple stuff. I have introduced you to tool. I assume that to some extent, உங்களுக்கு எல்லா டூலும் ஓரளவுக்கு தெரியும். So now I'm going to slightly do little what I can say. I'm going to use something called slider and all that. Very simple. Okay. So what I'm going to do is I'm going to construct congruent and similar triangles. I'm going to construct congruent and similar triangles. The very simple way you can create, but since I want to introduce you to some functions, I will do it in a slightly complicated way. Okay. So how do I do it? You can write the procedure also. If you are interested, you just write them. Take 2 points A and B. Any 2 points, wherever you want, you can choose. It is not necessary that you have to choose it horizontally. And you also do along with me so that you will follow what I'm doing. Choose a point A, B. First you do that. Now, in GeoGebra, this is called slider. Slider is like a variable. Slider is a variable. Okay. So I'm going to create a slider. How do you create a slider? Go to this place. Is there something called slider? And tomorrow you'll do more in detail. Okay. Next session, you'll do a lot of sliders. Today I'm just introducing you to a small part of slider. This is a slider. Click wherever you want on the screen, wherever you want. So there are 3 values. Number, that is real numbers. Other one is angles. The third one is integers. I'll choose numbers and I'll allow the number to vary from 0 to 180. Just follow this. Select the slider, click on the window, this window will come. Now, you take the minimum value as 0 and maximum value as 100. Increment will be 0.1. It will take by itself. By default, it is 0.1. It's a number. Don't choose angle, don't choose integers now. So, now you can just move around and see this. It's a variable. Now I hope you understand what a slider is. It's the slider name is A. It's taking different values. When you move it, it takes different values. It is a variable. I hope you understood. So what is the procedure? I started with A and B. I selected 2 points A and B. Then I chose a slider. In slider property, minimum value is 0, maximum value is 180. That's why I said this is slightly difficult. See, you please write down so you can try it later. Now I'm going to use a new command. You see there's something called rotate. The moment you start typing ROT, it will give you all possible way of rotating. Okay. I am going to select rotate object, angle, point. Rotate object, angle, point. I'm selecting that. Now in the object, I want to rotate B. So I will put B. I'll select B. Then go to the next one. Angle. This A is in degrees. I want to make it to radians. So what do you do? A into is that button on 8. You see 8. If you press shift and press 8, you'll get that star. A into pi. You can use just type pi. Pi by 180. It will automatically convert these numbers to radians. So rotate. What you want to rotate? B. How much you want to rotate? By an angle. What is that angle? A into pi by 180. About what point? About A. Press enter. Now just move it and see. Automatically, it's very beautiful. See, it will form a semicircle. If you're not able to see it clearly, we'll just drag it down. So the important thing about this activity is I can construct congruent triangle in a very simple way. But why I'm telling you this is, I'm introducing you to a new technique of forming it. The new command also. There's something called rotate. You can have rotate. Okay, so rotate B okay, rotate B one second. Now you can see it's rotating. Rotate B by an angle A star pi by 180 about A. Now you see there are three non-collinear points. You can always construct a triangle. To construct triangle, what tool I should use? Polygon tool. I construct the triangle. This is a triangle. You can rename all these things and or write it like I prefer to write it as B and rename this to C and rename this to D. Someone's mic is disturbance. Please mute yourself. Someone's mic is problem. Hello? Hello? Okay. Hello? 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 Hello, Radha ma'am.
சொல்லுங்க சார்.
யாரோ மைக் டிஸ்டர்பன்ஸ் கொஞ்சம் அதை அன்மியூட் பண்ணுங்க.
சொல்லுங்க சார்.
யாரோட மைக் கோழிலாம் கத்துது.
மைக்கா சார்?
ஆமா.
செக் சார். Deepa ma'am, can you please mute yourself?
இல்ல அவங்க இல்ல இருந்ததா கேட்டிருப்பாங்களே. நீங்களே மியூட் பண்ணிடுங்க. Okay. Now what happens is I measure this angle. The angle property. So you get all the angles. Once again, I'll repeat. You take 2 points A and B and use the command rotate, rotate, R-O-T-A-T-E, rotate B by an angle A about capital A. So, and then use the polygon tool and draw the triangle. So now my first step is to create a congruent triangle. See how I create a congruent triangle. For that, I'm giving you I'm introducing you to one more thing called vector. You see, there's something called vector. I'm using the vector tool. See, I select the vector tool. Vector is something that moves. Okay, it gives you direction. So wherever you want, you click and draw the vector. This is the vector, and the vector name is, I think it's U. Look at it. The vector name is U. It is actually 3.2i and plus 3.26j. It's a vector. Now, you see how I'm going to create a congruent triangle. I'm going to use the word, first you used the command rotate. Now I'm going to use translate. The moment you type, it will give you translate. Translate object and vector. Translate what object? I want to translate vertex A. Up in what direction? In the direction of U. Can you see? A is moved to A dash. A is moved to A dash. Again, I use the command translate. Translate. Now what I should type? B about the vector U. Now can you see? B is translated along this direction. Along this direction, B is translated. So this is one of the application of vectors. That is what I'm trying to. That is why otherwise I can construct a congruent triangle in a very simple way. Now again, translate C about U. I got all the three vertices. I think there's an alphabet problem, so it's actually this is A, this is B. I have to rename this to C. Otherwise, I'll get problem. So I have to type again, translate C about you. Now you can say I got all the three. Now use the Polygon tool and join this. So you got congruent triangle. Measure, you can measure the angles. Look at the angles, they are perfectly equal. And look at the sides. Look at the measurement of CDE, sorry, CDB. They are exactly the same. So they are congruent triangles. Look at the poly 1 and poly 2. Area also same. Area is also same. B1 dash. B1 dash is 5. And B is also 5. C is 5. C1 dash is also 5. D is 2.63. C1 dash, that A dash is, that is also 2.63. The A dash, that is 2.63. Look at it. Look here. 2.63, 2.63. 5, 5, 5, 5. So they are congruent. This is a way you create a congruent triangle. Now, what is the use of this vector? Move this vector and see. Always explore. Move this vector. So you can move the congruent triangle wherever you want. The triangle moves in the direction of the vector. So this is also like a little simple demonstration of vectors. So I have created congruent triangle. Again, I'll repeat the process. First, you have constructed the triangle. Now, to create congruent triangle, I use the command translate. Translate each and every vertex. Translate A through the vector U. Translate B through the vector U. Translate C through the vector U. You get the congruent triangle. Now similarity. For similarity, what I do, I need to create one more slider. So here the slider name is some E. The minimum value, I'll choose it as 0. You can do it in any way you want, 0. And the maximum value, I'll choose it as, say, 3, 4, 5, whatever you want, you choose. I chose it as 3. I got the slider. So first you command was rotate. First you learned what rotate command is. Then you learned what a translate command is. Now I'm going to introduce you to a third one called dilate. See, dilate what? Vertex A about what value? E. See, again, dilate vertex B about E. Now, dilate vertex C about E. Now, see this. Can you see? When E is 1, they all coincide. But when E is less than 1 or when E is more than 1, you get a smaller triangle. Now use the polygon tool and construct this triangle. And measure the angles. Measure the angles. We can see clearly. If I expand, you will see better. If you see clearly, 30.4, 30.4, 74.5, 74.5. They are also the same. So this is a similar triangle. And this is the factor. This is that A1 by AB by AC, that ratio. That is this E. So you can have a small. That is simple demonstration of congruency is same shape, same size. Similarity, same shape, different size. You see this. In this itself, you can bring congruency. It's congruent. Now it is. This is why you say congruency is similarity, but all similar things are not congruent. So here, first time I've introduced you to the three very, very complicated things. One is called slider. Second is vector. Third, you learned three very complicated commands. One is rotate, other one is translate, and third one is dilate. This will help you to shrink an image, to increase the. This is a simple application in similarity. You can apply it in wherever, in any place you want. You want to change the scale. This is very interesting. So this is simple demonstration of how to construct a congruent and similar triangle. Now let me repeat this once again. I spoke to you about file. I spoke to you about all the possible windows that you have. Then I showed you the move tool. What move tool does, you know it now. What a point on object intersecting point can do. Then we talked about line, segment of line, and finally we also introduced you to vector. Of course, we have not come to this yet. We'll see later. If we get time, we'll see. We introduced you to vector. Then we talked about perpendicular lines, parallel lines, perpendicular bisector, angle bisector. Well, these things we can come later. We can use this in statistics, line of best fit, etc. Then we talked about polygon and regular polygon. Rigid polygon, vector polygon, we are not interested right now. It is more for physics purpose, not for maths purpose. Now circles, there are different tools. You can explore the remaining. It is not so complicated. So we talked about circle drawn with center and through a point, a circle with center and radius, and you explore. And you can also verify this beautiful result. A circle passes through three non-collinear points. You see, you take three non-collinear points, you get a circle. Select it. It will give you a quick demonstration of how a circle can be drawn through three non-collinear points. We have not come to this yet. We'll see later. Angle. Then I talked to you about the distance and length. Slope we'll see tomorrow, hopefully. Then I have not touched this today. Slider. What is a slider? You learned. Text tool. Then how to use the move tool, and what is zoom and what is zoom out. These buttons are a little high level, so we will not touch that right now. So these are the things that I thought we will discuss today. If you have any questions, you can ask me. Otherwise, what I request is you should practice all these things before you come for the next session, where we will go a little beyond, a level beyond this. Not the same level, slightly higher. We will do more of calculus and other things. If you have no questions, you can leave. Otherwise, you can ask me some questions in case you have any. I hope I was not fast. Okay, I hope. Any questions? Okay then. Thank you very much. See you next. See you next.
Sir, shall I end the live?
Yeah, end the meeting. Yes. Thank you.